Alright guys, today we're going to be talking about dividing complex numbers, more specifically rationalizing the denominator. Now, as you notice in the denominator here, we have an imaginary number. And recall that the square root of -1 equals I. Now mathematically, we should not have square roots in the denominator. And again, the square root of -1 is I. So mathematically, we should not leave, those imaginary numbers on the bottom. We have to do something called rationalizing the denominator. And to do that, you're simply just going to multiply both the top and the bottom by the complex conjugate. And I have a video showing you how to find the complex conjugate. So if you don't know what that is, make sure you check that out. So in order to do this, we look at the denominator and we see that we have 2 minus 4i. Well, the complex conjugate here is simply going to be 2 plus 4i. And we're going to do that to the top as well. 2 plus 4i. And we're simply just going to do these operations out. Now this is going to be FOIL on both the top and the bottom. So what I'm going to do, I'm going to break this down into parts. I'm going to do the bottom first. So we have 2 minus 4i times 2 plus 4i. And now let's do FOIL here and figure out what we get. Well, if we do first, we get 2 times 2, which is 4. The outside and the inside, notice there that they will both cancel out, right? The difference of 2 squares. Because 2 times 4i is going to be 8i. And 2 times -4i will be -8i, and that will simply cancel out. So we don't have to write those. But let's do this. -4 times -4i, times 4i is going to be -16i squared. So that is what we have on the denominator. Now let's do the numerator. So I'm going to simply just do this right up to the side here. We have 5 plus i. And 2 plus 4i. Again, we're multiplying these. So again, do FOIL. So 10 plus 20i plus 2i. And we get plus 4i squared. And now let's just combine our like terms right here. We can combine these. So we have 10 plus 22i and then plus 4i squared. And now if we take a look, this is what we're going to have on the bottom. And this is what we will have on the top. And we can actually go further with this. So if we look and see that the square root of -1 equals I, well, what happens if I square both sides? So if I take the square root of -1 and square it, well, this is an equation, so I need to balance it. So this also must be squared. Well, we know that when we square, right, we have a square root, it's simply going to get canceled out. So right now, this becomes -1 equal to I squared. Well, knowing that, we can now replace our I squareds with -1. So why don't we go ahead and do that? So I'm going to write underneath here, we have 4 minus 16 times -1. Just simply replacing I squared with -1. And when we do this, we get 4 plus 16, and this all equals 20. So again, that is our denominator. We have 20 now on the bottom. Well, let's do the same thing here. I'm going to write it up here. So we have 10 plus 22i, and then we have plus 4, and then we're going to replace that with a -1. That I squared is being replaced with a -1. 10 plus 22i, and then -4. And let's combine our like terms. 6 plus 22i. So what I'm going to do here, I'm going to erase this middle part so I can rewrite the final answer. So remember, this is our numerator right here. Here is our denominator. I'm going to go ahead and just erase this. And when we put this all together, we will have 6 plus 22i all over 20. And now we can reduce this. Notice how they're both under the same denominator, so we can go ahead and break this apart. We will have 6 over 20 plus 22i over 20. And now let's just simply reduce here. So we know that 2 goes into 6 3 times. We know that 2 goes into 20, that's 10 times. And here we know that 2 goes into 22 11 times. And 2 goes into 20 10 times. And at this point we can leave it like this, or we can go ahead and write it all under one denominator. So we can write it like this as well. So or we can write 3 plus 11i all over 10. And this here is your final answer. Okay? And that is how you rationalize a denominator, okay, using the complex conjugates. And that's it.